previous class we were discussing about the time response of a second order system for the inputs, various inputs. Specifically, this graph was for the step input. So when we are giving a step input to the second order system, the time response looks like this, and this is for underdamped condition, right? So fine. So now we'll write the required equations for the calculation of the various parameters. All right. So if, let's say, input is step of, say, capital A units, this is A into U of t is the input. Okay, so the input R of t is equal to capital A times U of t. Okay, if this is given for a second order system with the same standard uh, equation of the transfer function, right? So that is omega n square divided by s square plus 2 times zeta into omega n into s plus omega n square. That's the standard equation. I think we have written a block diagram for the same, right? So you see this one, okay, with the feedback for this kind of setup. Now we are trying to write the equations, right? So what should be the output? Output is the C of t. This is equal to capital A times, this is 1 minus e to the minus zeta omega n into t all divided by square root of 1 minus zeta square times, this is sine of omega dt plus theta. So we need omega d. This can be written in terms of omega n and zeta. So this is omega n into root of 1 minus zeta square. So what is omega d called? It is damped natural frequency, right? And that's omega d. Then we have the theta, right? Phase angle can be calculated. Here, okay, okay. Sorry for the inconvenience. Okay, we were discussing about the theta. So yes, so the theta is calculated as follows. So how do you calculate theta? So theta is again calculated as, it's a phase angle. So this can be calculated as tan inverse of root of 1 minus zeta square whole divided by zeta. So this comes in radians. All right. So after that, from the above graph, we can find out all such parameters such as raise time, which is TR, the peak time, TP, maximum peak overshoot, right? Then we have the okay, then we have the TS, right? So these values we will be able to calculate. The okay, let's write the terms one by one. If you want to calculate the raise time, this is the equation. This is pi by omega d. Okay, then that's a raise time. Let's go for the peak time. So TP is equal to pi minus theta by omega d. Then we want to calculate, say, maximum peak overshoot. So this can be calculated as e to the power minus pi zeta whole divided by root of 1 minus zeta square. And the settling time Ts should be 4 by zeta into omega n. So this is actually for the 2% tolerance. Right. So we use these equations and calculate the time response of the second order system. Yes, this is the peak time. So time taken to reach the peak. This peak, how much time it's going to take from the beginning is the, yes, peak overshoot should above 1, how much it goes, all right? Above the desired value, whatever is the overshoot that happens. Let's quickly solve a problem based on this, all right? That is 3 by zeta omega n. Okay. Now, fine. Okay. Now let's take a question. uh, for the system shown, calculate omega n zeta omega d, okay, gamma theta, then tr tp mp, where ts for 2% and the c of t when unit step input is given. So this is R of S 20 divided by, this is S plus 1, S plus 4 is a forward path. Okay, you get a C of S as the output, and let's give a unity feedback, and the feedback is negative. Okay, so this is positive, this is negative. Okay, so from this I need to get the equation in the form of what you call the standard second order transfer function is what I want, correct? So we can calculate the C of S by R of S as This is g of s by 1 plus g of s into h of s, right? So g of s looks 20 by s plus 1 s plus 4 whole divided by 1 plus 20 over s plus 1 s plus 4. Okay, please simplify this. No problem, please take your time. Yes. Hmm. Okay, right. So 20 divided by, we have s plus 1 into s plus 4 plus 20, correct? Okay, so we want this in the following format. Because we want to get the values from the equation, so this has to be omega n square divided by s square plus 2 into zeta omega n into s plus omega n square. All right, so we want this format, which is not yet available. Maybe you have to multiply these two to get that. Okay, so multiply s plus 1. Yes, yes, correct, correct. 20 divided by this is s squared plus 5 times s plus 24. Right. So I note one thing from the required format, that these two terms should be same. So 24 I need to have it 24 here. Okay. So that means I will take 20 out and multiply and divide by 24. Okay, so that's the only option I have as of now. So what I do, I multiply and divide by 24, 24 over 24. So this gives me, so I'll take the 24 over here, 20 I will take it out, it's a multiplier. The denominator I multiply by 124, right? I'll keep it here. So 20 by 24 times, right, like this is 24 divided by s squared plus 5s plus 24. Correct. Now you can see omega n square here. Okay, this can be seen like a constant into the required format. Right? Yeah, yeah. Take your time. Okay. So now we got in the standard format. By comparing the terms, right, we can understand the following. The omega n square is 24, right? So which means we can directly calculate omega n as root of 24. Right, obviously plus and minus will come into picture, but we know why we don't consider the negative frequencies. All right, root of 24. Okay, so in radians per second, first value we calculate, and since omega n is known, from the denominator we can even extract the 2 times zeta into omega n should be equal to 5. Implies now we can directly calculate zeta, the damping ratio. This is 5 divided by 2 times omega n, that is 4.89. Sure, please take your time. 0.511 is the damping ratio. Okay, so once we get these values, then we can proceed with the other values, that's other values asked in the question. So you can see that omega d and theta can be directly calculated. Okay, so omega d is equal to omega n into root of 1 minus zeta squared. This is 4.89 into root of 1 minus 0.511 square. So normally omega d will be less than the omega n. Okay, so 0.20 is acceptable. This is again in radians per second. Okay, so once we have this, then we can calculate theta, right? So this is tan inverse of root of 1 minus zeta square by zeta. Tan inverse of root of 1 minus 0.511 square whole divided by 0.511. Sure, please take your time. Yeah, yeah, sure, sure. Okay. 'Kay, I think it looks like it's in degrees, right? Yeah, please convert into radians. Okay, this is 1.03 radians. Okay, so after we have this theta value, now we can calculate the raise time. Tr is equal to, from the equations we can know that Tr is pi by omega d. The omega d is 0.20. 0.747 seconds. And we go for peak time. This is pi minus theta over omega d. So this is pi minus theta is 1.03 radians or the omega d is once again 4.20. 0.502 seconds. Then the I think we can calculate MP now. So that value can be calculated minus pi zeta by root of 1 minus zeta square. So this is e to the minus pi zeta over root of 1 minus zeta squared. So this is equal to e to the power minus pi into the, it's here, 1 minus zeta squared. Only this much. Huh. It's only this part. So in the equation of C of t, you have that separate. You can just check this. So see, this is the other term. So this is, I think zeta value is 0.511 divided by root of 1 minus 0.511 square. So the result comes in a fraction. You can multiply it by 100 to get a percentage. How much it will overshoot. The minus is considered, right? The outside you have a minus of something. e to the power minus something. So just check that once. Ah, okay, okay. Raise it e to the power. Okay, then it will be. So 0.113. Yes, 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 yes. So into 100, this gives you the percentage, right? 11.3% is the overshoot. Then settling time is 4 by zeta into omega 0.511 into the omega n, how much? 4.89. Okay, right. Then we have what's the next question? That TS is over C of T, right? So the equation of C of T needs to be considered, right? So this is in general, first we'll write. So this is A into 1 minus e to the minus zeta into omega n into t whole divided by root of 1 minus beta square times sine of omega d into t plus theta, right? So how do you get the a part? If at all there is a you will be able to identify the a over here. It's other than the transfer function, so this becomes the a. Okay, so this is the a, and we are going to use this a over there. So 20 by 24 is the a part. So this is equal to 20 over 24. So multiply this with the 1 minus e to the power. So let's substitute the value. Minus 0.511 into omega n is 4, 4.89 times t whole divided by root of 1 minus 0.511 square into sine of omega d is 4.20 times t plus the theta is 1.03 radians. So only we need to simplify this term. This and this we need to simplify. So the 20 by 24 becomes 0.833, 0.833 times. This is 1 minus, this is e to the power, this is 2.490. This also we can actually bring it to the numerator as the 1 by root of 1 minus 0.511 whole square, right? That term will simplify and write uh, as a term in the numerator. Sure. 0.511 square. Yes. Okay. This is 1.163 times e to the power minus 2.49t into sine of 4.2t plus 1.03 is the equation of output C of t when the input provided is a unit step function. Okay. The data can be given in a different format, right? So I'll show you how a different type of data can be given. Okay. Uh, Consider the system represented by d square C of t by dt square plus 4 times d into C of t by dt plus 8 times C of t is equal to 8 times this is R of t. So here the C of t represents the output of the system and R of t represents the input of the system. Now the question still remains same. Alright, so that is find these values. Calculate omega n, zeta, right, etc. Right, so I'll just copy this part as it is for the system shown over there. Find out all these values. Yes, 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 yes. Once again, the same thing. Okay. Now, how do you convert this into the standard transfer function is important. That's what is important now, right? I need to convert this into the transfer function. Once you have the transfer function, then we can proceed, right? How to do that? They have given a differential equation. They have not given a straightforward transfer function, and it's not even in the block diagram format. Hmm. See here, they have not mentioned whether the C and R are corresponding to. Yeah, is again, it's not mentioned anywhere that whether this itself is a mechanical or this represents a electrical. It's not given, right? So, but we can see that there is a d square by dt square, indicating that this is a second order, something related to that. Can you convert this into a second order, what you call transfer function? So, how to convert the differential equation into the transfer function? You look at the domain, right? So, this is given in the time domain because the equation is in terms of t, c of t, r of t. What do you need for transfer function? Which domain? S domain. So it means it has to be the Laplace transform. So take a Laplace transform of this given equation, and then we'll see whether we can, right, obtain something. Okay. So that whenever the equation is given in the differential equation, this should be the first step. Okay. So taking Laplace transform, right? If C of t has a C of s, right? C of t becomes C of s in the Laplace. What happens to the d square C of t by dt square? So this is the representation. C of t has the Laplace transform C of s. Let's assume that R of t, which is in the time domain, has the Laplace transform R of s. Then now I need to write what happens to the dc of t by dt. What happens to its Laplace, and d square c of t by dt square, take its Laplace, what happens? No, you see here the C of t is not given like is it C of t is U of s or something, right? Right. So that's not given. So C of t becomes C of s. What happens? The differentiation of C of t. It's a differentiation property of Laplace transform. What happens when you differentiate the time domain signal? What happens on the S domain side? Okay, no, no problem, no problem. Anyway, I think in the requirement you sent there is one whole chapter called Laplace transform. Correct? Okay, we'll discuss in detail over there. Now I'll tell you the answer. Okay, so this is simply multiplication by s. Okay, s into c of s. So double differentiation generates a s square. Okay, into c of s. Whatever is the c of s, it comes over there with the multiplication of s. So the number of times you have differentiation, same number of times you get multiplied by s. What inverse? S will be coming. So this is known to. This should be known to you first. Okay. What for a given c of t? What is for a given c of t? What is its Laplace should be known. Then if you differentiate this to get a new signal, its Laplace transform can be directly calculated by simply multiplying by s. Okay, same thing holds good. If you know C of t and C of s, that pair, differentiating twice will give you this d square, which whose transform can be directly calculated as this. Okay, directly you can calculate. We don't have to perform the Laplace calculation once again, right? That's the property. Okay, all right. So now what we do, we use this and we'll calculate the Laplace of the given question. All right, so there is a differential equation given. Let's directly calculate its Laplace. So that means this is equal to, so we have the first term as d square c of t by dt square, correct? So that simply transforms into s square into c of s plus there is a 4 into dc of t by dt becomes simply s into c of s. Correct, once differentiation happens, then we have 8 times c of t, so this is plus 8, c of t becomes c of s equals to, this is 8 into it's the input, so r of s. Right, so now we can take the c of s outside, so this is c of s into s square plus 4s plus 8 is equal to 8 into r of s. Correct? So what is the transfer function now? Therefore, transfer function t of s is equal to output by input. As they mentioned, output is c of s, input is r of s. So c of s by r of s is what we need. Correct? So c of s by r of s has to be 8 divided by, this is s square plus 4s plus 8. So we arrived at the transfer function. This looks like omega n square plus s square plus 2 zeta omega n times s plus omega n square. It's already in the required format. The 8 which we can see over there, it's the required values. Okay, so I think now onwards you can proceed further, right? Calculation of all the other parameters. Please take that as a homework. All right, so solve that, and in the next class we'll continue to the, I think the steady state is the part left over in this, right? Once we understand the concept of steady state, directly we go for the stability. All right, so this is done. You copy till here. All right, so we'll meet in the next class then.